All right. And it's good to have someone I can do eye contact because I can envision that you're an audience and I can interact with because that's my mode. All right.
So why are these things so critical to a data center facility?
Well, there's several reasons. One primarily is safety. The grounding system is the basic principle of any power distribution system. It's one of the first things that one should be thinking about in terms of electrical installation is the bonding and grounding system. Safety. You want reliable safety. You want your equipment to be safe to operate, to touch, and you want the people inside the building to be safe, such that you don't want someone shocked when they touch a piece of equipment. You don't want a difference of potential. Also, you don't want a difference of potential between different components inside the equipment that for example, insulation breakdown or things that are bonded and grounded at different potentials that can cause differences of voltages, that can cause currents to flow, that can damage sensitive electronic equipment. Data centers have a tremendous amount of capital investment that can easily be destroyed by deteriorations or ineffective bonding and grounding systems. Another purpose would be reliability. For example, if your system is not effectively bonded and grounded to the system, then it's going to behave differently other than as designed and intended. Consequently, the reliability of the data center and its processes, its functions, its business plan is going to be dramatically altered because an effective grounding and bonding system is important to that system. It's much like keeping your car lubricated and your oil changed and your tires inflated. You have to maintain those things after they're properly installed. There is the assumption that they're properly installed the first time. That is not always the case in data centers. In many cases, data centers are constructed to the basic minimum standards of the National Electrical Code. However, what most people don't realize is that the National Electrical Code is not a performance document. It's not a design document. It's actually just a minimum, and I want to stress the word minimum installation requirement. However, the minimum installation requirement pursuant to the characteristics of the National Electrical Code, or the mandates of the National Electrical Code, are not always applicable to data centers. You can have a data center that's installed and meets the requirements, the minimum requirements of the National Electrical Code, and still be a substandard application relative to the high-tech requirements of a data center. The national standards always lag behind the technology. The National Electrical Code is no example. It has a 3-year cycle. There can be enhancements, advances in technologies that are often going to be reflected in the construction and operation of a data center for which the codes have to play catch-up. And we'll talk about some of those issues during the course of this presentation, where the code had to play catch-up at what was happening in the industry. Another example is performance. You want your power systems to stay, I'll use the term healthy power. That's going to become more of an issue in the 21st century. We're going to talk about healthy power and the need for reliable, healthy power. Data centers need healthy, reliable power at all times. Any deficiencies in a bonding and grounding system will directly affect the reliability of the system and the performance of the system relative to electrical power distribution inside of a data center. You want to minimize cost. If you have deteriorations in your bonding and grounding systems that exposes your systems, for example, to more susceptible to transient events. One of the leading causes of damages inside data centers are caused by surge events. Now, surge events can initiate from the utility, or they can be caused by a direct lightning strike to a building, which is very common, or you can have potential rises inside of a building from a lightning strike that's not even near the building, could be outside the building, where you have current flowing underneath the building, and you have potential rises that occur between a lot of equipment inside of a data center. Data centers have a lot of distribution. They have a lot of mainframe metallic cabinets, a lot of structure. There's raised floors. It's nothing but a catacomb of metallic parts. Very easy to have differences of potentials, surge events during a surge event, or have difference of potentials during a surge event that cause damaged equipment. Most people do not maintain or effectively operate a grounding system. They think after it's installed, it's there forever, I don't have to worry about it. That's a misnomer. Grounding and bonding systems deteriorate over time and require maintenance, just like the energized components. Usually what we find in data centers is that we find problems after there's been an event, and not before, because there's been no proactive maintenance or inspections or enhancements. So, one other thing, break. I've been doing this work professionally for about 35 years. In my professional experience, which kind of drove me to focus on grounding and bonding systems as a profession, is that I find that 70% of all anomalies in power distribution systems can be directly correlated and directly traced to grounding and bonding issues, be it from dysfunctional ground fault protection, no ground fault protection, potential rises, arcing ground faults, surge events, deterioration insulation over time, transient voltage conditions, differences of potential that causes arcing and tracking or breakdown of insulation directly related to grounding and bonding, or people getting shocked or equipment damage directly related to grounding and bonding, or equipment connected at different potentials inside of buildings. I'm stunned and amazed some of the older data centers where a facility that's an older building that was taken over and refurbished for a data center, and they connected to an existing deteriorated substandard electrical system, and they put a multi-million-dollar data center inside an existing building that was put in the 1970s or 80s without doing anything to the infrastructure or not inspecting the grounding and bonding systems. Most likely they're substandard, and in many cases we've found them to be that way. And then shortly after operations, they find that they start having anomalies and problems. They have a high loss rate or downtime directly related to grounding and bonding. Okay.
What's the approximate time code block there?
Am I talking too long in each
No,
segment?
no, this is great, but I want to make sure, because we want to talk on that point about 70% of what you've seen. I thought I
Where
made
we're
a
at right now?
note here, yeah.
We're probably about 14 minutes
So that's probably about
real
what,
content.
1.5, 2 minutes, what you just said about one other point he wants to drive home, he's an out.
Yeah, you were probably a
and
minute and a
analyst.
half to 2 minutes on that.
Okay.
So do we need to expand or shorten?
No, that's good. I think how do you feel, Marcus?
We got plenty,
Okay.
and so.
Don't you wish they were all this
Yeah.
easy?
Yeah, it leaves us plenty of room to edit too, so.
Okay. One other thing, I want to jump off topic here because you started to go into your experience.
Mhm.
So can you give us just a little snippet of what your role and expertise is so that we can qualify you as our
Okay,
expert
okay.
on film?
All right. We'll do an introduction. My name is Frank Waterer. I'm an engineering fellow with Schneider Electric. I've been with Schneider for about 22 years. Prior to that, I was a private consultant and I was a staff engineer at Duke University. Started out, I grew up in this profession. I'm the fourth generation electrical contractor and engineer in my family. It became very familiar to me. I grew up playing with electrical conduits and wire nuts and things, and worked in this field during the summer months and later got into it. Didn't plan to be that way, it just worked out that way. It's something that's very comfortable and very easy for me. I love the work. The volume becomes a little cumbersome at times, but I do enjoy the work. I started out in the profession installing electrical equipment, focusing a lot on grounding and bonding. Used to do, and I still do to this day, I test ground systems and ground grids, but one of the things I did was go out into a field and do soil resistivity test to determine if an area was a good place to put a substation, 138 kV substation or 15 kV substation.